Engineering Exploration Course Project. Myself Rakshita Hiremet and my team members are Karthik Naik, Manjunath Baswa and Spurti Puja. Under the guidance of Padmaja K. Our project title is Silk Thread Winding Machine. We were given a need statement which was wire-winded coils are used in motors, solenoids, inductors and many other electrical equipment. Today, coils winding are no more preferred by laborers. Industrial machines are much efficient and fast in doing this job. An industry which manufactures such machines is interested in making ready a small-scale demo machine. The 5 steps of engineering design process is 1. Problem definition, 2. Conceptual design, 3. Product architecture, 4. Detailed design and 5. Design communication. With the help of this design process, we were able to define our problem as follows. Design a semi-automatic winding machine. It should be portable and user-friendly. Machine should be able to release thread and also accept the thread. It should cut at any particular length and it should wind silk thread. Machine should indicate the user after winding process is completed. And also the machine should not exceed the mentioned dimension and also should be under a budget of rupees 2000. Function 3. After identifying the problem definition, we were able to identify what all the functions we need. We have handling the big spool function, which means the handling the big spool includes the sensing the thread and the rotation of the spool and also refilling of the spool. Handling of the small reel includes hold the reel, sense the thread and release the reel. Indication function includes machine on and off, that is the state of the machine, and also cut the material, that is indication of that the material is cut, and also at final the process is complete. Casing is for the wrapping of the wheel. To simplify the functional tree, we clustered it into 3 different units, that is spool handling unit, reel handling unit and interface unit. We also identified the subsystems for our machine, which is spool unit, cutting unit and uniform thread guide unit. Brainstorming session with the team helped us generate these concepts. On the left hand side we have our concept 1. This concept has an DC motor connected to the reel with the help of pulleys and a band or a belt. On the right hand side the concept 2, wherein we have 3 different types of reel and the spool is of triangular form or conical form. But the concept 1 has the cylindrical spool. We also have 2 other concepts. Those are on the left hand side of the screen, that is concept 3. We have a pulley attached at a certain height from the ground and also other pulleys at the bottom to rotate the reel. On the right hand side we have a DC motor and a shaft in a manner of a zigzag way, which will zigzag way connected to the shaft at the other end of the reel. And also we are in this concept 4, we thought of using gears and relays and Arduinos and much other shaft cutter and as for the concept. Selected concept. We selected concept 1. We ended up with this concept because PugChart declared this one as the winner, wherein the PugChart had high scores for concept 1. We as a team sat down and gave scores to each of the concept 1, concept 2, concept 3 and concept 4 for different kinds of categories like safety measures, standard components used and as such. This concept concept received high number of scores in safety measures. Our team's main intention was to create an model or system which is more user friendly and high safety. This concept also uses a lot more standard components like DC motors, servo motors and Arduinos. So ultimately, this concept had high priority compared to other concepts. So this concept became our main concept and we proceeded with this concept. After completing the Pakchat process and selecting the concept, we went through virtual implementation process. With the help of AutoCAD, which is a software where we can develop a 3D model for our system. On the screen, we can see the design which we created on AutoCAD. This is where the reel unit will be mounted, and these are the motors which will help in cutting and also uniform thread guiding, and this is the spool unit. This is the side view of the model. We identified the different subparts we need. The first one is the cutting unit, second one is the uniform thread guide, and the third is the spool. After completing the 3D modeling on AutoCAD with the help of circuit.io software, we developed this circuit which has two servo motors connected to the Arduino on the breadboard and also DC motor subsequently connected to the breadboard as well. Flowchart or Simulink model of the entire system. Just to sum it up, this flowchart, start when the system or the machine is started, we will intake an input and then the LED blinks. As the LED blinks, simultaneously the DC motor and the servo motor 1 turns on. The DC motor will turn on to rotate the reel. The servo motor will turn on for guiding the thread uniformly towards the path of the reel. This entire little process will complete winding of the thread. Then when the process is completed, there is an indication with the help of blinking of LED. When the blinking of LED is done for the winding process, the servo motor 2 turns on for cutting. When the servo motor 2 cuts the thread, again the LED blinks to indicate that the thread is cut and the servo motor 2 turns off and the entire process is stopped. This whole process can be repeated again for another set of reel. Bill of materials required for the entire system. Just to sum it up, we'll be needing a base of foam sheet and also DC motor which will be attached to the reel side. The reel will be of plastic. Servo motor 1 for uniform thread guiding. It will be fixed in a box-like structure with the help of foam sheet. Microcontroller Arduino Atmega as well. Spool will be of plastic as well. Nuts and bolts of M4 size LEDs and stand for holding the reel above the base will be structured in the form of L shape with the help of foam sheet. Motor sizing and battery sizing of the entire system. Basically, we will be needing two kinds of motors like DC motor and servo motor. DC motor for output reel and one of the servo motor for cutting unit and the other for uniform motion of the thread. Calculations underdone will be using an DC motor of 15 RPM, and servo motor 1 and servo motor 2 voltage required will be of 5 to 10 to 12 volts. Functional specifications of the entire system. Function. Hold the spool. A plastic rod mounted perpendicular base will be used to hold the spool erectly. Hold the reel. Reel is placed at an angle of 45 degrees with the help of two stands. The stand, which will be an approximate of 7 to 8 centimeters in height. Indicate the start of the process. To indicate the start of the process, we will blink the LED. To release the silk thread from the spool, a DC motor will be attached at the reel side, which will drag the silk thread smoothly with the help of pulleys to wind at the output, that is reel. To indicate the end of the process, again the LED blinks for a second again. Winding thread tightly. Guide the thread uniformly so that the reel is winded with silk thread uniformly so that there are no lumps of winded thread at one single place. Uniform threading. The article used for uniform threading should be perpendicular to the base and should have hole to pass the silk thread through it. Cutting the silk thread. The blade should move in to and fro motion that we can easily cut the thread. Modeling and simulation. To help analyze more about our system and how it will behave in real life, we went through the Tinkercad. Tinkercad helped us to simulate the model. We developed a circuit which will behave the same as in the real life. Simulation video. To achieve the simulation and analyze, Tinkercad was helpful. Tinkercad is a software wherein we can combine the code we have written and the circuit which we have designed. When the simulation is initialized, at the first we will intake an input, which is the number of reel count. Enter the reel count. Entered number of reel is 1. Will be displayed on the serial monitor. As soon as this is done, this LED will blink, will be turned on, and then the servo motor 1 and DC motor will start working. The servo motor 1 will move in between the 40 to 60 degree, which will help the thread move in uniform way. This servo motor ensures that the thread moves in uniform direction to the reel side. The rotating of the reel will drag the silk thread from the spool part successfully. Since this process should be continuous and work for certain number of time, this code of the DC motor and servo motor was written in the void loop, which helps the keep process going on for certain amount of time. As soon as this winding is done, the servo motor 2 turns on for cutting of the silk thread. The silk thread, since it is very easy to cut, a small sharp blade which will be attached perpendicular to the servo motor will cut the silk thread evenly. This servo motor will also be moving around 40 to 60 degree angle. As soon as this cutting is done, there will be a display on the serial monitor to indicate that the entire process is done. You can see that there is a display of done. So this code is designed in such a way that we can wind the silk thread not just for single reel at a time, but also two reel in a single time, like when we enter reel count as 2. This code will run 2 times. The whole process will repeat for 2 times, as in when the first reel is completed, when the first winding of the reel is completed, the machine or the code is designed such a way that it will wait for certain seconds wherein we can quickly change the reel and replace the fully winded reel with an empty reel which is to be winded. So in this way we can continue this process for n number of reels as well. Software and resources used. We have used AutoCAD 2019 for 3D modeling and Circuit.io for developing the circuit diagram, and Tinkercad for the simulation and also the circuit, Draw.io for flowchart, and the entire documentation and report is on GitHub. Thank you.